Hello everyone, this is Udadit again from TechSpark, bringing you another session covering data engineering Q&A. And in today's session, we're going to discuss the fundamentals of AWS EMR. So as usual, I'm going to start with my brief introduction. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an integrity profile with our comprehensive course covering all the necessary topics of data engineering. So what is AWS EMR? AWS EMR is Elastic MapReduce. That's how it is termed, and it provides you a big data cluster or Hadoop cluster along with all the other services like Apache Spark, Hive, or Pig, whatever you need. So it will simply create a cluster and it will have all those tools for you to process the data. The only difference between an AWS EMR and an on-premise cluster, in an on-premise cluster, you have to set up everything on your own from the scratch, whereas EMR will provide you a redundant cluster with all of this already installed. So EMR processes big data across Hadoop cluster of virtual servers on Amazon Elastic Compute Cloud or EC2 and Amazon Simple Storage Service, that is S3. So we have already seen S3, it works like a data lake. You can put any sort of data, be it structured, semi-structured, non-structured, and you can process the data using other services, and EMR is obviously one of them. So EMR under the hood is actually an ensemble of different types of EC2 clusters, sorry, EC2 instances. And if I talk about EC2, that itself is another service of AWS where you can create and also maintain a VM, that is a virtual machine. The only difference between EC2 and EMR is that EC2 will allow you to create one virtual machine and then you have to do all sort of setups. Okay, if you need to deploy some application or if you need to create a Hadoop cluster, you have to do all those things by yourself using EC2 instances. Whereas EMR will provide you a cluster of EC2 resources, a cluster of EC2 instances where each and every tools, the big data tools will be already pre-installed. And if I take a look at the different EC2 instance types, so they are categorized based on requirement. Some are like general purpose, then they're like compute optimized, memory optimized, and they're storage optimized as well. So if you need more CPU, you can go for the compute optimized. If you need more RAM, you can go for the memory optimized. And if you need for more storage or if you need some more hard disk, in that case, you can use the H, I, or D, these categories. So for each and every category as well, you will see different classification. Like if I, for example, if you look at this chart, for T2 there is T2 nano, micro, small, medium, large. So it is like self-explanatory, right? For each and every different class or for each and every different kind, there are different sort of cluster resources. And the shift from, if you gradually shift from nano to small to medium to large, you will see with the increasing amount of cluster resources such as the CPU, RAM, the cost also gets increased, right? So you have to pay that much amount. So you have to pick a instance that is well suited for a requirement. Like if you want a memory optimized, you can go for the R1s, and from the R1s you have to pick how much do you want to pay. Will it be small, large, medium? Accordingly, you have to pick the cluster resources, and you would have to pay the same amount. Okay, so this is about the EC2 instances and how they form in EMR. Now let's take a look at different pricing models of EC2 instances. Okay, so in EMR, since it's not going to be a single node EC2, a single node cluster, so it will comprise of different EC2s, right? And different EC2s, and this categorization or classification of EC2 comes in the pricing model as well. Okay, so what I mean, so suppose you have picked one memory optimized R4 with the medium amount of cluster resources. Okay, R4 medium you have picked, right? You will be paying some amount. So that amount also that can be adjusted based upon what kind of pricing model you're choosing. So first is the on-demand or the standard one. Okay, so that means that this will you have to pay whatever the amount by hour. Okay, you will have a short-term spiky unpredictable workload. It cannot be interrupted, will never be interrupted. Okay, you have a steady state server and you can use it and you can turn it off when it is done. If I talk about spot, so here is the big difference comes. Okay, so it is up to 90% savings, and the reason being that spot instances can be interrupted anytime by AWS. So whenever AWS needs, it will take it up, and then you will be sitting with nothing. Okay, so there is obviously a caveat. Like if you're using a single node cluster, if it's just one instance and you're picking the spot because you want to save some money, but you see that that has been taken away by AWS, in that case, you totally lose your application or what are the jobs that are running, right? So that is the reason you have to be very specific when you're choosing. If you're going for some practice session or test session, you know that you'll be just running for an hour, then it will be gone. You can pick a spot instance. There is no harm. Then there are other classifications as well. One is the reserved, the other one is the dedicated. So the reserved one you will get 75% off, but you have to commit to the EC2 over 1 to 3 years of time. Okay, so meanings you need a cluster where you need the instances for a very long time. Okay, you know that the jobs will be running and you want this application to go over for years. In that case, you can pick the reserved one, and the last one is the dedicated. So what is the difference between dedicated and reserved? Is that dedicated servers, it can be on demand or reserved. It will have like almost 70% off, but it is when you need a guarantee of isolated hardware. So it is totally a customized setup, basically on enterprise level. Whenever the industry needs to set up an AWS EMR cluster, so that is when the dedicated service comes up. Whereas for the reserved one, you can resell the unused reserved instances, but it is not possible when it is dedicated. So it will totally be to you. You will be the owner of that cluster, and then simply AWS. You just have to pay the AWS that amount, and that's it. It's totally yours. You cannot resell the unused instances, or you cannot simply just change the instances whenever you want. Okay, and even with the pricing model, so there are different groups you can select. Like since AWS EMR is an ensemble of EC2 instances, like it is going to hold up different nodes. So there are two different kinds of cluster you can use. One is the instance group, the other one is the instance fleet. So instance group is like a fixed groups of instances categorized by role, master, code, task. Okay, what is master, code, task? I'm coming to this later. Then the pricing options are, it supports on-demand and spot instances, but you must define them explicitly. Okay, meaning that you can either choose on-demand or spot. You cannot pick a hybrid one. So if you're picking on-demand, obviously you have to pay by an hour. It's like a steady step. And if you need a spot, in that case, all the instances in your group shall be spot instance. You cannot take a hybrid, like there will be some on-demand and some spot. And the scaling is also a bit tedious because you require manual scaling. You must add or remove the instances manually or use some auto scaling policies. Now coming to instance fleet. So it's a collection of EC2 instances of different types and purchasing options, that is on demand and spot. So there is the option where you can pick a hybrid cluster. You can choose a hybrid cluster where, say, suppose you need out of 15 nodes, 10 will be on demand and 5 will be spot. So what will happen that it will save you some bucks, right? Previously it was 15, all of the 15 were on demand. Now you have a hybrid setup. So spot will eventually save you some money. So yeah, accordingly, the pricing option allows mixing on-demand and multiple spot instances types of cost optimization, and also the scaling is very smooth over here. More dynamic scaling, EMR can automatically replace the spot instances and that get terminated. Like spot instance can be terminated or taken away by AWS itself, right? So in that case, you may need new spot instances. So AWS will do the scaling automatically. You don't have to put any sort of policy or any manual intervention is required. So there is a difference between the instance group and instance fleet, and the different pricing models, how you can save some money when you're building up an AWS EMR cluster. Now, last but not the least is the auto scaling. So how auto scaling works in EMR, right? EMR, the term elastic. Elastic means that it can scale up and down whenever it's required. So there are some scaling triggers based on different metrics such as yarn metrics, HTTPS metrics, then CPU utilization. These metrics can be visible in another AWS service that is known as the CloudWatch. But see, these things are totally like admin work. You don't have to maintain the servers by yourself. Okay, this auto scaling and everything, this is not a developer's job, but it's obviously important for you to understand, to be knowledgeable. Even in case in some interviews they might ask you that how do the scaling triggers are orchestrated in your project, so you will have to come up with some answers. Okay, so yarn metrics such as, there will be the Spark job or any application running in yarn will have some container memory, and also contain the CPU usage and everything. So based upon that, if it crosses any threshold limit, in that case, it will simply scale up. HDFS metrics will simply focus on the disk utilization. If the Hadoop storage is getting full, in that case, the scaling policy will be triggered and automatically the cluster will be scaled up. Okay, otherwise you can use the CPU utilization for scaling, and there are some custom metrics as well. You can define your threshold, like if my memory usage is getting like 80%, in that case probably add some one or two nodes to my cluster, and that's how you can scale it up. Or the vice versa as well. If you see it is only using 20%, probably you can just reduce two nodes and I'm good with it. Okay, so which I just mentioned, the scaling up and the scaling down, meaning adding instances and removing instances, happens the same way, triggered when a metric exceeds a set threshold. New instances are added to the meet demand to meet demand. For spot instances, EMR selects the best price instances. So when scaling up, as I was talking about instance split, right? So it's a hybrid setup between the spot and the on demand. And since the spot can be taken up by the AWS at any time, okay, which are known as the interruptions. So whenever the spot instances goes down, then AWS EMR takes it on its own to replace them with newer spot instances. Now talking about scaling down, it is again the same thing triggered when resource usage drops below a set threshold. EMR gracefully decommissions instances, ensuring running jobs are completed. But if I'm using all the core nodes, okay, let's talk about core nodes, master, and the task node. So there are three different kinds of nodes in EMR. One is the master node. So since the big data framework itself works in the master slave architecture, so master's node is will instruct the all the other nodes, and also it will keep the metadata information, whereas the core node will be used for processing as well as the storing data. But if I talk about task nodes, so they will only process data, but they won't store any data. Okay, so if I try to scale down or remove any core nodes, before removing the core node will check if any of the data that is residing there in Hadoop is properly replicated or not. If it is not, in that case, it won't get shrunk or it won't be triggered down. Okay, so that's about it. And the task node, we can use spot instances when it comes to task node, because even if the task node goes down, AWS takes away. In that case, the data is not there, right? So I'm not losing any data. Other task node will come up and the processing won't halt, because be it Hadoop or be it Apache Spark, they have the fault tolerant ability. If one of the node goes down, then they will simply consider all the other nodes. Okay. So there is another way of auto scaling, and that is for instance fleets, right? And it is modern recommended. So whenever I'm using instance fleet, so I don't have to put up any kind of policy at all. EMR will dynamically select the best instance type based on the pricing and availability, and it supports spot price fluctuations. The spot price has this kind of like a fluctuation. Sometimes it goes down, sometimes it goes a bit high. So whenever it goes a bit down, then only it will pick and add them into the cluster by replacing the terminated spot instances. And no need to mention that it is more efficient and cost optimized. So that's all about auto scaling. So that's all about EMR, how the cluster is formed using the EC2 instances, how the scaling is taken care of in order to deal with the growing and expanding data. So I won't be doing any. So this is totally theoretical session. I won't be setting up any EMR cluster today. And in the next session, I will set up an EMR cluster. I will see you how we can pick these instances, and then I will also submit a Spark job just to get an understanding of the EMR cluster. So that's all from this session. You can reach out to us. You can reach out to TechSpark to know more about our comprehensive data engineering course. We cover almost all the necessary tools such as Apache Spark, Hadoop, Hive, AWS with hands-on coding and real-world project. And we also offer some job assistance whenever you're done with the course and your interview and your profile is interview ready. So do reach out to us in case of any help. Me, Udait, signing off from this session. See you on the next one. Bye-bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpark.